Hi everyone. The second it's pointed out that everyday observations like the path of the sun across the sky or things appearing to sink as they cross the horizon disproves the ridiculous notion that the Earth is flat, flat earthers use the excuse, "But perspective." But of course that's just a word they've learned to regurgitate whenever someone points out that reality conflicts with their professed beliefs. What are their stupid claims? And more importantly, what are some situations where perspective actually works against them? This is FLERFPRATT. Flat Earth points refuted 1,000 times. Don't forget to rate the video, subscribe, and hit the bell. Flat Earthers get one thing and only one thing right about perspective. That in a situation like the one depicted here, as the distance between the observer and the object increases, the object will appear to approach the horizon. Pretty much everything they get wrong about it, they get wrong because they don't understand why that is. The angular height of the object is determined by the relationship between the actual height, d, and the distance to the observer, r. This relationship is easily derived using simple high school trigonometry. And when the distance is significantly greater than the height, which flerfs believe it usually is, the angular height in radians is well approximated as d over r. The angular size of an object is inversely proportional to the distance to it. So yes, by the standard flat Earth model, as the sun moves to twice the distance from the observer, the angle between it and the horizon should be cut in half. Yes, it should appear to move closer to the horizon. But since by that so-called model, d is approximately constant and r is always a positive number no greater than the distance to wherever the sun is in zenith, alpha never reaches anywhere close to zero. As we discussed in part 1 of this series, assuming that the sun is at a height of 5,000 kilometers, approximately 3,000 miles, as flerfs usually claim it is, and that the sun is always in zenith at a point between the tropics, which flerfs usually accept, the angle between the horizon and the sun can never get smaller than 8.7 degrees anywhere on Earth. So no, sunsets cannot be explained by perspective. On the flat Earth, the sun cannot set ever unless it sets as seen from everywhere on Earth. Furthermore, as the sun moves away from the observer, the angular distance across it should decrease as well in accordance with the same formula as the angular height. And this is not what we observe. But the sun isn't the only thing flerfs claim disappears from sight because of perspective. Apparently that's also why things sink as they cross the horizon. This is backed up with obvious lies about how if you just zoom in enough, you can bring them back into view. Backed up by images where a detail can't resolve zoomed out, but it can resolve zoomed in. And of course the camera that's supposed to be able to bring obstructed objects back into view is the magical Nikon P900.
Optical zoom works by decreasing the camera's field of view, so the object you're zooming in on occupies a greater portion of the image. This means a detail that can't be resolved on a zoomed out image could still be resolved on a zoomed in one. A detail that is obscured by the curvature of the Earth, just as a detail obscured by any other obstacle, won't show up in the image because the camera, just like your eyes, doesn't have a line of sight to it. Reducing the field of view won't change that. You'll see a zoomed out image showing just water with nothing sticking up at the horizon and a zoomed in image showing a city skyline. Fine. The buildings were too small to resolve on the zoomed out image, but you'll never see the cars driving on the streets because only the tops of tall buildings are tall enough not to be blocked by the Earth's curvature.
So what's all this about the P900?
The Nikon P900 is a DSLR camera which was in the slightly below $1,000 price range, lens included, before being replaced by the P1000. It's a consumer-grade camera, perfectly fine for your holiday photos, but probably not something a professional photographer would use. Professional-grade DSLRs start at about $5,000, and I can easily find professional-grade lenses that cost even more than the camera itself. And yes, you definitely get what you pay for. The P900's claim to fame is that it comes with a 24 to 2000mm lens, which allows for 83 times optical zoom. FLERFs take this to mean that it has better zoom capabilities than even professional-grade telescopes, the lenses of which have far lower focal lengths. Even this $40,000 professional-grade reflector telescope has a focal length of 1,500mm. Since the focal length is what determines the magnification of a lens, this leads to the idea that any image showing something in the sky that can't be captured in equal resolution with a P900 must be CG, because no better camera and no greater magnification exists. This is simply so far from true that only a FLERF could make such a stupid claim. Yes, the magnification of a single lens is determined by its focal length, but the magnification of an entire camera or telescope depends on more than the focal length of the objective lens, as there is another lens in there as well, at the eyepiece of the telescope or where the lens connects to the actual camera. So in both cases we have two lenses. Reflector telescopes also use parabolic mirrors to focus the light even more. Our professional-grade telescope has a maximum magnification of 800 times. Even this $90 300mm refractor telescope, marketed as suitable for children and beginners, gives you 150 times magnification. A toy telescope kicks the P900's ass. FLERFs. This is a consumer-grade DSLR camera, ideal for taking pictures of a view from your hotel room, animals when you go on safari or bird watching, or hot chicks at the beach from a safe distance so no one calls you a pervert. While it has sufficient magnification to take pictures of craters on the moon or show the Galilean moons of Jupiter or the rings of Saturn, it's not actually designed for making astronomical observations. This is. And no, neither piece of equipment can take pictures of things they don't have a line of sight to simply by zooming in.
To get back to perspective, we also have to talk about crepuscular rays, or sun rays, or God rays as they're sometimes called in the visual effects industry.
FLERFs use images like these to prove that the sun is close. We've already shown how we can know it's not in an earlier part of the series, but of course they don't care. The idea is that if it were distant, crepuscular rays should be parallel. And I completely agree. It's just that they are. Just like these rails. We tend to notice crepuscular rays when they're coming toward us, and FLERFs, who are so fond of claiming that others are not taking perspective into account, are forgetting to take perspective into account.
Perspective. They don't know what it means, and they want to keep it that way. And that hypothesis is further supported by idiocy like this.
Of course, the claim is that this distance, which is this distance projected onto the plane perpendicular to the line of sight, obviously can't be 93 million miles. But no one says it is. It's this distance that's 93 million miles, or 150 million kilometers. They don't understand that the sun is farther into the image than the Earth. It's way in the background. They don't understand that this two-dimensional image is of objects in three-dimensional space. In other words, they don't understand perspective.
Next, let's have a look at this classic piece of FLERF stupidity.
How big is North America? These guys making these fake images can't make their minds up. The inconsistency apparently proves that space agencies are lying to us. Of course, the explanation is perspective. When you observe a sphere, how much of its surface is visible to you will depend on your distance to it. Observe. This observer can see this part of the sphere. Let's put a dark area here in the middle of it. As we move the observer closer to the sphere, the observable area gets smaller, but the size of the dark area remains the same, so it ends up occupying a larger portion of the observable area. This image is taken from a great distance. This image is taken from much closer to Earth using a wide-angle lens. The different size of North America relative to the observable area is because of perspective. Again, it's the people who scream, "but perspective," who fail to take it into account.
Now, why would that be? Obviously, it's because the flat Earth model is completely inconsistent with the principles of perspective, whereas the actual model that is consistent with reality, the one where the Earth is a sphere far away from a very, very large sun, is perfectly consistent with the principles of perspective. And flat earthers know this. As usual, they're wrong. They know they're wrong, and they want to be wrong. See ya.